Hi everyone, I'm David, and I'm here to talk about Safe Haskell. So this is joint work with Terei, Simon Marlowe, and Simon Jones. So just to give you a bit of a motivation, Haskell's a really great language for building secure systems in. If you look through sort of ICP papers and Haskell symposium, there's been quite a bit of research work over the years on things like information flow control, capabilities, and working on encrypted data. Unfortunately, none of this work actually secure data in the real, secure code or data in the real world. So, as a sort of more concrete running example, I'm going to be using that website built in Haskell, where you want to be able to take in untrusted third-party plugins, and users can install those against their account. So think of something like Facebook. And the way we'd like to be able to do this is to sort of carefully craft a plugin interface that uses types to restrict the functionality that plugin authors can execute. So a very simple way would be just to allow only pure functions, but we need type safety guarantees for this to work. So here's a function that we all know and love. It's always promoted one of the advantages of functional programming of Haskell, of being able to reason purely on types. But unfortunately, this is a perfectly valid implementation for this type. So the solution, Safe Haskell, of course. So Safe Haskell can be built consisting of three components. The first is that of a safe subset of the language, and what it intends to do is provide enough guarantees. So by itself, it's not some security framework. So by itself, it provides enough properties, enough guarantees about what Haskell is capable of, that secure systems can be built on top of it. The second component is that of a safe import extension. So this allows you to specify that a module that you're importing has to be a trusted module for the import to succeed. And the third component is a definition of trust. So how this applies both to modules and to packages. So to start with the safe language. The safe language is providing three guarantees. The first is of type safety. The second is of guaranteed module boundaries. So what I mean by this is that you shouldn't be, in the safe language, if you import a module A that doesn't expose a certain private constructor, there should be no way for you to actually access that constructor. And third is of semantic consistency. So this is two components in a way. The first is that the safe language is strictly a subset of Haskell, so we don't want it changing the meaning of Haskell. So a module that compiles in the safe language should have the equivalent meaning to when it's compiled without the safe language. And the second component of semantic consistency is that we don't want untrusted code redefining the meaning of existing modules. So if I import a module that uses a safe language, it shouldn't be allowed to redefine any existing code in my code base. And one important thing to note is that these properties, except a little bit for the third one, what we kind of usually think of Haskell having. So as many people have said, unsafe perform IO is not Haskell. So in a way what we're doing is we're kind of codifying, well, what are sort of core features of Haskell? What are we really sort of, what are the guarantees that we want from the language? So on to the restrictions that are applied by the safe language. The first is that foreign function interface imports have to live in the IO monad. As they're outside of sort of GHC's knowledge, we have no guarantees about them, so we provide them in the IO monad. Rules aren't allowed to be defined. These can be used to violate the semantic consistency property. We don't allow template Haskell either. It's quite easy using template Haskell to craft, so to get access to private constructors, so to violate the module boundary. Generalized interactive deriving. This might go from the list. Based on discussions, this might be more a bug in implementation and design probably. But basically, at the moment, you can use generalized interactive deriving to create code that could not otherwise create by hand. And if you sort of carefully manipulate this, you can break invariants that are established by a module through its export list. We don't allow handcrafted instances of data that are typable, since these can be variously used to do unsafe versions between types. But we do allow derived ones, since these are sort of machine generated by GHC, so they're safe. The second last point is overlapping instances. So this is restricted because of the semantic consistency principle. We don't want to allow untrusted code to define a more specific instance than already exists in the code base and change the meaning of the existing code. So we don't just outright restrict, turn them off, but we restrict the functionality. So a module using the safe language can define overlapping instances, but they can only overlap instances also define that module. So a nice way to think of this is like a same origin policy. And the final thing is, in the safe language, you can only import other trusted modules, since none of these guarantees we can prove hold unless we have this property. So back to the example. What we would do is we would compile the untrusted plugin using the safe language and use types to control its functionality. And we're done, right? Well, not exactly. The problem with this is that so far the only way I've talked about to define trusted modules is the safe language. And we want to ideally we want to allow access to modules like data byte string, which internally use things like unsafe or IO. So the thing with these kind of modules is that while they might use unsafe functions internally, the API they expose is safe. And by safe, I mean you cannot use the API of data byte string to violate any of the three properties I've talked about. So this brings us to another parameter, that of the trustworthy parameter. And this basically allows the module author to declare that while my module might use unsafe functions internally, the API it exposes is a safe one. So trustworthy doesn't place any restrictions on the Haskell language. It does mark the module as being trusted. And basically it's up to the module author to guarantee that these three properties, namely type safety, can't be violated simply by using the functionality the module exposes. It enables one small extension for safe imports, which I'll be getting to shortly. So trust though. So what determines if the module is actually trusted? Well, there's two pathways. The first is the safe language. So if a module successfully compiles in the safe language, then it's considered trusted. What about trustworthy though? Well, that's a little bit more complex. As I said, the trustworthy parameter doesn't apply any restrictions on the safe language, and it's up to the module author to guarantee that these properties hold. And that's a very easy avenue to abuse for untrusted code. So what we do, the way we limit the scope of trustworthy, is we require the client, this is the person who's actually kind of running GHC, assert that they trust the module author, so the author of the module using the trustworthy parameter. And the way they assert this is they say that they trust the package that the module resides in. So to give a bit more of a concrete example, non-student might mark the data byte string of the module as being trustworthy. This would potentially allow untrusted plumbing to import data byte string, but only under the condition that the website administrator has marked the byte string package as trusted. So this gives you a little bit of a sort of handle on controlling how trustworthy is used. So we can think of trust in this sense. For the safe language, the trust is provided by the compiler. But for the trustworthy parameter, we have a bit of a chain. Initially, the trust of the module is stated by the module author, and then the trust of the module author is stated by the client by trusting the package. Trust is a transit property. So you might have module A that uses the safe language, but this may still entail for A to be trusted that package P is trusted. Since in the transitive dependencies, there may be a module that is using trustworthy flag that resides in package P. This is the interface that is exposed for manipulating package trust. So using the GHC package tool or passing command line flag to GHC itself. Okay, so the final component of Safe Haskell is that of safe imports. So this is just one small extension we made to the Haskell language. Basically, it allows you to place a requirement on an import that module has to be trusted for the import to succeed. So under the safe language, as I said, all imports have to be trusted imports. So this flag, you can still use this the safe keyword, but it's implicit and redundant information. Under the trustworthy, by default, the imports standard neutral Haskell imports. And it's up to the module author to choose if they would like to sort of place a requirement on an imported module that to be trusted. So this is allows a little bit more flexibility in how you craft and design trustworthy modules, as you may want to sort of state that this module exposes under the guarantee that some of the modules we're importing are trusted.
So if I say command install something, it installs a zillion packages.
Yeah.
Are they installed trusted or not?
I'm getting to that. Wait, the packages, sorry?
So I say command install, something, and it installs 17 packages.
Yeah.
Are they installed as? Am I declaring that I'm trusting them or not?
Yeah, I'm getting that now. Okay, so the point that Sam raised is one of the problems we had in the current implementation of Safe Haskell. So this is in 7.2. Basically, it's a problem with the definition of how package trust operates. And from high level, what it does is it causes Safe Haskell to be very invasive and kind of affect the world. So once 7.2 was released, it was very common to see people posting to the GHC main list with build errors. Basically because in 7.2 by default packages weren't trusted. And that meant that a lot of the time people would be trying to install another package or build a GHC, and there would be a requirement for the build to succeed that the package is trusted. So all of a sudden, a user who's unaware of Safe Haskell, or even that are aware of Safe Haskell, it's not the feature they want to be utilizing, has this requirement to go around trusting certain packages on their machine. So it kind of made Safe Haskell an opt-out feature as opposed to an opt-in one. So what we've decided to do for 7.4 is that by default, trustworthy modules won't have a requirement that the package they live in is trusted. Instead, there will just be the simple check that, well, by default, the trustworthy fragment will just imply that the module is trusted. Now this is quite unsafe though, so to get the old behavior back, there will be a new flag, tentatively called package trust, which enables the old behavior of checking that the package itself is trusted with the module resides. And now this flag should definitely be used if you are relying on trusted code, but it enables Safe Haskell to be an opt-in feature and not sort of infect the world.
So wait, let me see if I understand this. So you explained that this trust business is a combination of the author and the customer. Right? So Don, the author, says my module is trustworthy by saying that check is trustworthy.
Yep.
I install his package. Among many others, I didn't even know I was installing this package. And I think you're saying that by default, I'm now going to install it trusted. But if I say -f package trust, then I by default install it untrusted. Is that what you mean?
Well, by default, they will be installed untrusted, but we won't be checking whether a package is trusted or not. Right?
Okay, so by default, then we just ignore. We'll say,
by default,
we
matter if it's trusted.
Okay.
And then to get the behavior of checking that it's trusted, you put on this flag.
Alright. I see. Okay. And then you individually go out and say, yeah, I trust Don.
Yeah.
Okay.
The other change we are applying for 7.4 is that about improving the safety of the module. So we can statically detect that you're not using any unsafe features, then we'll simply mark the module as being a safe module. And part of this means that you'll have a new parameter, the unsafe parameter, and this is basically to stop sort of the inference of the module being marked as safe. Because there might be a module that, while it doesn't use any unsafe features, you don't want it to be imported by untrusted code. Potentially has some data constructors or private data that you don't want untrusted code to be able to access. So just to sort of come back to the example, bring it all together. This is kind of how you might very simply go about crafting such a website or such an interface with untrusted code. So the first thing we have is we have this Rio.unsafe module, which simply has a new type wrapped around the IO monad. So Rio is like input output. And notice here that we've explicitly marked this module as being unsafe. Because this module exports the constructor for the Rio data type. And the whole point here is that we want to control what IO actions are executed, so we need to control what can be considered a Rio type. And so we don't want untrusted code to be able to import this module. The next module is the Rio.file access, and this enables two operations, reading and writing a file, both of which are protected by this path function that implements an arbitrary security policy. The next module is the module Rio. So this just imports the two modules we've seen. And presents a unified interface for plugins. And notice it's been marked as trustworthy, so that an untrusted code, so a plugin can import this module. And finally, we have skeleton of what a plugin would look like. And it's using the safe language so that it's machine checked. And it simply has one method, which uses the read or data type. So we can guarantee that this untrusted code, while connected to IO actions, the only ones we can do are the read and write file operations we have provided, which are protected by the pathway case security policy. So just to sum up, we have 3 new language characters that are safe, trustworthy, and unsafe. There will be one new flag, the package trust flag, and we'll also be inferring the safety of the module. The tagline can be thought of as trust your types. Future work that we want to do is kind of go about doing this in sort of a more formalized proving manner. So the approach we're taking so far is really to start with the entire world, so GHC Haskell and all its glory, and narrow it down to cut out parts that we know are unsafe, largely through the basic intuition. And so the more interesting approach would be instead start with a small sort of proving core that has formal semantics and that prove to base set of guarantees, and expand outwards, including extensions as we can sort of establish that they also obey these guarantees. That's Safe Haskell. It's in GHC 7.2. Please try it out and give me some feedback. Thanks.
Questions? So, what happens if I trust Dom, but I don't trust Neil? But Dom trusts Neil. And I install byte string, and I trust Dom, but it uses something that Neil has written.
Then you'll have to trust Neil, or you'll have to not trust both of them.
But I mean, I don't know what, I will have to inspect the byte string package then to see that it uses something that Neil has written.
So,
or can I say on the command line?
When you say something that Neil's written, is that included in the byte string package, or where is that?
Yeah, so the byte string uses
Dependency
something.
of the byte string.
Okay, so dependency is another package.
Yeah.
I think you need a paradigm.
Okay, so when you import, it's because the trust check is transitive, when you try to use data with byte string, you'll then get an error that you haven't trusted.
But it might not be transitive. I mean, I trust Don, but I don't trust Neil. But Don trusts Neil. But I don't trust Don enough to...
You don't trust his judgment.
No, I trust the code that he writes, but I don't trust his judgment. So,
Okay, but so to use data with byte string though, there will be a requirement that Neil's package is trusted.
yeah, by me. Okay, so I have to go through...
Yeah, the trusting of the package is 100% on the client machine. So there's no way, like, Don can establish a requirement that for his code to work, Neil's package has to be trusted. But you still have to
Okay, so,
grab that privilege.
so when I install bytestring, I might have to go through 17 packages and see, okay.
Potentially, yes.
So when you say GHC package dash trust byte string, you'll
Yes.
say, no, you can't do that because it depends on an untrusted package. Go make that trusted first.
I think it'll just fail with the compilation error, but we should probably look at doing that.
Not compiling anything, it's GHC package, right? You're saying
Oh, okay.
that's really the moment it fails.
It won't do that at the moment. That's
Okay.
I need to show.
Strong reports. Yeah, that's what it should. Right? That's what you want.
Yeah.
Yeah.
Well, I mean, I would like to not to go through all these packages. I don't want there to be some concept of a package author or something like that I could trust or not trust. But I'm not sure how to connect all these things together in the same way that it's...
Yeah, there's some interface ideas worth considering that.
I think it might be reasonable to have a package at the top of the base tree that's trusted. It still depends on the package that it's open, because the model modules within this at the top package that actually below the down. So I think you try to get information at that level when you
Yeah.
So this is great. It seems that you've already given us quite a lot here. Correct me if I'm wrong, I think this is already enough to be able to do a web server that executes untrusted client code, if you're willing to also use process level isolation. Because there are two big untracked effects, being allocation and non-termination. But it doesn't seem like much of a problem to take untrusted code, link it against some kind of harness that runs it, and then run it in a separate process and use ulimit to keep its memory under control and kill it if it runs for too long.
Yeah, definitely. Like I said, we're trying to provide enough guarantees. So things like unlimit are very much outside the scope of the Safe Haskell. So
So while it's safe for the web server, it wouldn't be safe for a different application.
This is just
Yeah.
defining your restricted mode, right? You can
Right.
that operations.
But then your restricted monad can't be in a library, so you can't add. So an application can do it, provided no one else is going to reuse it. But you can't put that kind of parameterized different permissions model into a library.
Yeah, there is a point here in that we are slightly utilizing the trust between things. We want to track some guaranteed types, but we are kind of using it a little bit as a way of controlling imports. And there might be sort of a way, there might be a design of splitting these two separate things out. But yeah, at the moment they're sort of convoluted together a little bit.
I commented on this yesterday, those of you who were at the meeting, this work, and I'm hoping that people will see the significance that I think is here. First of all, I think it's a big deal, the comment that was just made here, that this framework, for the first time with Haskell, actually gives us sufficient ability to load code into something like a web browser, unknown code, and have some kind of guarantees that what the type system says about them is actually true. And that alone is just a great thing. But I think the actual real implication of it is that, for me anyway, it seems to give an insight into what the long-term evolution of Haskell will be in terms of how we think about unsafe perform I/O and the other dangerous kinds of things. That comment that you had at the end of the previous slide about starting with the sort of foundational piece that we have, I don't know what they'll be, 5 or 6 kind of golden properties for Haskell that good code should satisfy. Things like not violating the type system, referential transparency, respecting name boundaries on modules, things like that. That we will establish those as a community, that this is what a true Haskell program does, and any time that you step out of that, you have to provide some level of guarantees that gets reflected in a notion of safety that allows that thing that's stepped out of it, nonetheless, to live in the world of good Haskell programs. So to me, this really introduces a way forward for a problem that has plagued us for, when did you go and introduce it? 95? It is part of the paper.
So useful.
Any more questions?
So just one comment, maybe we should start advertising our package, extract and colour differently depending on how
I actually had I put patch them had it to put safety, that's the note at the top.
To complete a little bit on what Neil said, is this kind of a type system for modules? Right now it's not much, there's safe or not safe, but you could sort of think of more properties that you can attach to them, and then they get these properties all together in some particular way, and you might be able to parameterize them or what have you.
Well, I think there's that somewhat, but that's kind of a viewpoint. But I mean, with the other point, I did think of that it might be worthwhile pursuing sort of another mechanism, but I think we want to complicate the design any more than it currently is, or being able to sort of control or make sort of establish some, I guess, sets of packages that can be ported or not ported, like sort of relations.
So actually, I think that Neil's point can be addressed with other security mechanisms within the HV at the type system level. But the second point about, say, tagging the module. So I think, say, just using unsafe is maybe not enough. Maybe having unsafe. So ideally, what I'm thinking about is, say you have the security library and it has a TCB, but then you want to export a safe subset that is used by these unlisted modules. So we could just tag it on unsafe. Right now, you can't even define your safe interface. So being able to say, like having, in a sense, like multiple tags to say which one can actually use it and which one can't.
I mean, modules containing calls to error might be considered bad in some sense because they can fail at runtime. Maybe I won't have tag.
And then you want someone to say, like, trust me, this won't
source level, so you will have to, the easiest way you just write shit, right? You write a model with three sports type, basically mark that as trustable. But you can't sort of after back to mark logic as trusted.
So why does the author have to say it's trustworthy to begin with? Because if they claim they audited the guy.
Yeah.
But they could say that they qualify if they wanted to, right? Because you still have to trust it. It's just one place they can put the information saying that they audited.
Yeah, there were some discussions in that regard. I can't remember how far we took this thought through. I think there was some complication in the compilation sort of issues, but I mean, we can wait offline.
So saying trustworthy, you're just saying that the types of
Yeah, I mean the types correct will take three properties, right? So types, modular boundaries, and standard consistency. But I mean that large comes out to trusting types.
The last question.
If there's time. So one thing I didn't hear in the talk was an argument for what the advantages of Haskell are for unsafe code execution versus say JavaScript. And well, I can let you answer, or I can say that.
So I mean, I'll do my as best as I can, but I guess that wasn't a huge concern for me. I would say it's mostly to do with the powerful type system. So I think when you have such a sort of flexible powerful type system and things like monads, it really increases what you can do at the language level. So I know that like previous work on the examples I gave, so like on the information flow example, has mostly been done by modifying the language. And the great thing about Haskell is you can do that just at the library level. And I'm not really aware of sort of how language to give you that sort of flexibility.
Right, so something like JavaScript, you essentially gives you a single version of that RIM on that. And you don't get to pick it or configure it or do it around.
Yeah.
Are all JavaScript plugins safe?
They're safe according to some limited system of specs. They can store things locally on the client. They can do a few things, but they can't write it
Like
down.
the sandboxed.
So there are actually capability systems that are implemented in JavaScript, but they're using it as a subset of JavaScript. And there's all kinds of static analysis. And well, for language like JavaScript, you can do it kind of with separation logic using oriented approach.
So if I'm setting up a server, I can say I want my JavaScript code to be able to use these capabilities and not these.
Right. So
untrusted.
Right. So if you're running with Node.js, you technically run untrusted code as long as